Okay, so here is a little bit of a brief tutorial for the notes on Trig, so you guys can go ahead and start working on your packets. I'm using practice worksheet A from 8.1, which should be your day 1 worksheet. So that'll last you Monday and Tuesday, and then Wednesday and Thursday you'll do the second one, and it'll be just the side B of this. So you should be okay with side B once we do this together. First of all, you want to remember that to remember your trig functions, people say so, ka, toa. That represents these first 3 trig functions. So the S in so, it's sine is opposite over hypotenuse, which is what we have here. Cosine is adjacent over hypotenuse, which is what we have here. And then the tangent is opposite over adjacent, which is the third one. So these are your 3 main ones, and if you can memorize those for the sides, then you'll be able to memorize or know these, because all they are the reciprocals. So this is called cosecant, this one is secant, and this one is cotangent. And if you notice, sine is opposite over hypotenuse, and then your cosecant is hypotenuse over opposite, so you just flip those. Same thing for cosine and secant, and tangent and cotangent. Okay, so for example, theta actually is the angle measure, and we'll put that down here in this bottom corner. It does not matter what corner it goes in, but that'll be your starting point for all of your problems. So if we have theta down here, we want to do the opposite. The opposite side is going to be directly across from theta, so it's literally opposite of theta. So this is the opposite side. The adjacent side is this one that touches theta. So this is the adjacent. And we know that our hypotenuse is always across from the right angle. So that's just basic triangle stuff there. You know the hypotenuse is the longest side, and it's always across from the right angle. So if you can remember these, then everything should be perfect. All right. This is from your worksheet. Example 1 is number 1 from the worksheet. It looks like this. And it says to evaluate the 6 trig functions of angle theta. So I went ahead and wrote them here. You can write them on your paper. And they have theta in the upper corner. So that's where we start. And step 1 says to use the Pythagorean theorem to find the third side, which you guys have known how to do for a while now, I think. Maybe we need a refresher. But remember, the Pythagorean theorem is a squared plus b squared equals c squared. Okay, a and b are your sides, and c is always the hypotenuse. So these two are interchangeable. It doesn't matter which one you use for which, as long as c is the hypotenuse. So I'm going to make a 15. So we have 15 squared plus 12 squared equals c squared. Okay. So 15 squared gives us 225 plus 12 squared, which is 144, and that's going to equal c squared. So 225 plus 144 gives us 369 for c squared. And to find c, we take the square root of 369. And so if we do that, let's see, we'll take the square root of both sides. And then let me see what that breaks down to, because you're going to have to want to break this radical down. So let's see. So it breaks down to 9 and 41. So if we have the square root of 41 times 9 equals c, remember the square root of 49 or 41, that doesn't exist. So the square root of 9 is 3. So our answer is 3 square root of 41 equals c. So once you know this, then we can fill in all of the trig functions. So I'm going to go ahead and write that up here, 3 square root of 41. All right, so let's go ahead and determine which sides are the opposite, adjacent, or hypotenuse. So starting from theta, remember, opposite is directly across from theta. It's the opposite of it. So this one's opposite. This one is going to be the adjacent because it touches the theta. And that leaves this one to be the hypotenuse, which we knew because it's directly across from the right angle. So once we know that, we can fill in these. Sine uses opposite over hypotenuse. So theta, here's the opposite. So 12 over the hypotenuse, which is 3 square root of 41. Now remember, we cannot have radicals in the denominator, so we have to rationalize this. All that means is if I put this down here so we can see, let's see, 12 over 3 square root of 41. If we multiply that by the square root of 41 on both, or the top and the bottom here, we're going to get 12 square root of 41 over, and then you'll do 3 times 41, which is 123. Okay, and let's see, 12 over 123, that reduces to 4 square root of 41 over 41. Okay, so this is our new answer, for sine. So it'll be 12 square root of 41 over, 4 square root of 41, not 12, over 41. Okay, once we find that, cosine is adjacent over hypotenuse, and we said adjacent is 15. So it'll be 15 over 3 square root of 41. Now we're going to have to rationalize that. So the same way we did this, we'll have 15 over 3 square root of 41. So you essentially just bring this to the top. So 15 square root of 41, and then do 3 times 41, which we know is 123. So all we have to do now is 15 over 123 and see if it reduces, and it's 5 over 41. So it's 5 square root of 41 over 41, and that'll be cosine. So I'll put that here. Tangent is the other one that's left, and we said tangent's opposite over adjacent. So here's our opposite and here's the adjacent. This one's easy. So it's 12 over 15, but we still have to reduce our fractions. So 12 over 15 is going to reduce to 4 over 5. Okay, once we know these three, all we have to do is flip them to get these because they're the reciprocals. So if I were you, I would flip the first one that had the radical on the bottom, because when you do, it's going to bring it to the top automatically, and we won't have to rationalize. So let's flip it, and it'll be 3 square root of 41 over 12, and we know 3 over 12 reduces to 1/4. So it'll be the square root of 41 over 4. And that'll be your answer for cosecant. Secant, we're going to do the same thing using this one. So it'll be 3 square root of 41 over 15. And 3 over 15 we know reduces to 1/5. So the square root of 41 over 5. And then we just flip this, since it's already reduced, to 5 over 4. And that is our answers for number 1. And you'll do the same thing on number 2, which those are smaller numbers. So hopefully you can do that. If you have questions, just message me. All right, moving on to example 2. Let me turn the camera. Okay, so example 2 here, actually, I don't know, is number 4 on the worksheet. So we do the same thing, but now we're given 4 over 11. Like, that's all we're given. You don't even have a triangle. So you always want to draw a triangle first. And we're going to find the other 5 trig functions. So we know that sine is 4 over 11. Automatically, we know that cosecant is going to be 11 over 4 because it's just the reciprocal. We just flip it. And now we only need to find these 4. Okay, to do that, we're going to pick an angle to be theta, which I'll pick this bottom angle. All right, sine uses opposite and hypotenuse. So from theta, the opposite's going to be over here. We know the hypotenuse is here, and the adjacent will be here. So using that, sine is opposite over hypotenuse. So it's going to be 4 over 11. And now we just have to find the adjacent side using the Pythagorean theorem, which we know how to do that too. So 4 squared plus b squared equals 11 squared, because remember, c always has to be the hypotenuse. So this gives us 16 plus b squared equals 121. If we subtract 16 from both sides, we get b squared equals 105. And when we take the square root to find b, we're going to leave it as the square root of 105 because it does not break down. So knowing that, the adjacent is the square root of 105. Okay, we've labeled what we knew, we found the other side, now we just have to write the ratios. So cosine, it uses adjacent over hypotenuse, so it's the square root of 105 over 11. That one was easy. Tangent uses opposite over adjacent, so that's going to give us 4 over the square root of 105. The square root of 105. And remember, when we rationalize that, we just bring this to the top. So it'll be, I didn't leave enough room there. 4 square root of 105 over 105. So when there's nothing else down here, we just leave that number. Okay, so we need to flip secant, or to get secant, it'll be 11 over the square root of 105. When we rationalize that, it becomes 11 square root of 105 over 105. And 11 over 105 does not reduce. So we'll leave it like that. Okay, so now we have to flip this one, and remember, I would suggest flipping the one with the radical in the denominator, because when you do, it'll come to the top, and it's the square root of 105 over 4. And we just leave it like that. So that is number 4 on your worksheet. So these are your answers. Okay, example 3 is a little different. Now we're finding the value for x. On these, we're given this triangle. The first step is to figure out what sides we're using. So from 30, we always start from the angle given, whether it's theta or an actual angle. So from 30, x is the opposite side. It's directly across from it. And this side is directly across from the right angle, so 10 is going to be the hypotenuse. So which trig function uses the opposite and the hypotenuse of the 3 main ones? So if you look at these 3, opposite and hypotenuse is sine. So we have the sine of 30 equals opposite over hypotenuse, so x over 10. That's how you'll set that up. So from 30, it's the opposite and the hypotenuse, which is sine. So we write sine of 30 equals x over 10. Okay, now when we have, there are things called special trig functions, and I have put a copy of the chart in Schoology under the helpful resources folder. So make sure you're looking at that. And it is, let's see, if you go to Schoology and helpful resources for the emergency packets, if you click on special trig limits, it'll bring this up. And so right now we're looking at the sine of 30. So to read this, here's our sine, and you go over to 30 degrees, which in this case it's 1/2. So the sine of 30 is 1/2, and you do not have to memorize these, but they are very helpful to know. So I should preface this by saying we use this chart only for the special trig angles. So that would be 0, 30, 45, 60. We're not going to be using 90 because the 90 degree angle is already solved for in our triangles. So that is for something else, but we are going to use these three, 30, 45, 60. And if we ever do get back to school, I have these copied for everyone to use on anything that we do. But for now, just get on here and look at it. You can download it or whatever. So here, we said that the sine of 30 is 1/2 and it equals x over 10. Now we just solve for x. In this case, we can multiply both sides by 10 to get rid of that. And then we're left with x equals 10 times 1/2, which is 5. So our answer for this is x equals 5. Okay. All right, so we only have one more example, and then down here, if this is you looking up at the sun, I know you guys like my little pictures. This is your eye level here, and you're looking up at the sun. This is the angle of elevation. So if we were to make this a triangle like this, then the angle of elevation is in that bottom right corner. The angle of depression is what is from the sun looking down at you. So it's like on the outside of the triangle. So the angle of depression would be like over here somewhere. So I made a little note that says they're equal. The angle of depression and the angle of elevation are equal angles. They have the same degrees. So always put the angle for a word problem in the bottom corner. So whether you draw your triangle like this or like this, you always want theta or whatever angle they give you to be in the bottom corner. That way you know you're getting at least that part right. So example 4 is number 10 from the worksheet, and it is a word problem. So it says a parasail rider is attached to a boat with a rope of 80 feet, or that is 80 feet long. The angle of elevation from the boat to the parasail rider is 36 degrees. Estimate the parasail rider's height above the boat. And we went around to the nearest tenth. So if we're doing that, we always draw a triangle for our word problems because that's what we're working with, our right triangles. Okay, always draw your right angle. Now it says the angle of elevation is 36. So even if it said the angle of depression, we would always put it down here. So 36 degrees. And it also tells us that the rope is 80 feet long. So if the rope is 80 feet long, you have to determine which side that's going to be. So if you picture yourself parasailing, remember the boat, or if you've ever seen it at the beach or anywhere, here's the boat and the parasailer is like up here. Here's you, you're parasailing. All right, so the boat is here and you are here. You're attached to a rope from the boat to you, so this is going to be the 80-foot rope. And we want to see, what's the thing? Estimate the parasail rider's height above the boat. So if this is the 80-foot rope, the height is this one. So we want this to be x. That's what we're going to solve for. Now this is set up just like the last problem, but now it's not a special angle. We have to use the calculator for this. So from 36, we always start at that angle. What side is x? And it's directly across from it, so it's the opposite. The 80 is directly across from the right angle, so that's going to be the hypotenuse. So if we know the opposite and the hypotenuse, that means it's sine. So we're going to write sine of 36, because that's our angle, equals x over 80. Okay, to solve for x, we'll multiply both sides by 80. And then these will go away. So x equals 80 sine of 36. If you have a graphing calculator or any calculator that has trig functions on it, you just type in 80 sine of 36, and I'll show you how to do that on here, but you will do 80 and then sine 36, 36, enter, and that'll give you not the right answer. So if you come up with a negative number, go to mode. You want this to be in degrees. Okay, so now let's try that again. So we scroll up. That's better. So 47 degrees. Well, not degrees in this case, but 47 feet is going to be our answer. Now, if you don't have a scientific calculator, I'm going to link a couple onto Schoology so that you'll have access to it. But that is how you do those examples from the worksheet. If you have any questions, just message me on Schoology.